Okay, you guys, for this next part, it's going to be a little similar to what we did above. However, what makes it different is above, I gave you the angle. So if you want to think of it in terms of an angle, or if you want to think in terms of S, right, either way, it's the same thing because R is equal to 1. But here what I'm giving you is the ratio, and we're supposed to find S. So that S tells you right away that we're a circular function. We are definitely in radian mode. I'm kind of being a little helpful here because I'm also saying let's find the exact values of S in the intervals from 0 to 2 pi. But technically I don't need that right there because just telling you the sine of S is the square root of 3 over 2 definitely tells you in radian mode. As opposed to if this was the sine of theta equals the square root of 3 over 2, right? That theta could be in radian or degree mode. So that's another little significant thing that's happening here now that we are circular functions. And what we're basically going to do is use our cheat sheet. All right, so we have some exact values, and we'll go to our cheat sheet, our little unit circle here in a moment. Excuse me. So, but let's use old knowledge. So the sine is positive. Well, we know that that happens in quad 1 and quad 2. And what we're interested in y values, right? Y values that are equal to the square root of 3 over 2. So when I go look at my cheat sheet, right, I'm basically going to be looking in quad 1 and quad 2, and I'm specifically looking for y values that are equal to the square root of 3 over 2. So one of them happens at pi over 3, and then it happens again at 2 pi over 3. So our S, right, our arc length, if you would, right, is basically pi over 3 or 2 pi over 3, right, which also matches the angle of rotation in radian mode. So that's basically how you answer that. The next one, cosine of S, again, on radian mode, is equal to negative a half. Well, where's cosine negative? It's negative in quad 2, and it's negative in quad 3, and we're very interested in x values. I want x to equal to negative 1/2 in quad 2 and quad 3. So when I go look at my cheat sheet, again, we're going to focus on quad 2, and I look, and there's x equal to negative a half. So S is equal to 2 pi over 3. But if we look into quad 3, right, where there's our negative a half there for our x value, so that corresponds to 4 pi over 3. So those would be our two values within the first rotation, right, that make cosine equal to negative a half. We could just see it by looking at the x coordinate in quad 2 and quad 3. Over here, the tangent of S is equal to negative 1. Well, again, where is tangent negative? It's negative in quad 2, and it's negative in quad 4. And we're looking for basically a ratio, right? Y over X has to be negative 1. So basically, they're the same but opposites. And so, if you need the cheat sheet for this, but hopefully it's pretty clear, right? Here, X and Y are opposites, and they're the same, right? So we're definitely getting a ratio of negative 1 here. So one of our solutions is 3 pi over 4. In quadrant number 4, right, where's that ratio? Right here, right? Because x is positive, y is negative, but they're the same. So if I divide them, I'm going to get negative 1. So we got 7 pi over 4. Okay, so the tangent of S, the arc length would have to be 3 pi over 4 or 7 pi over 4 for that to happen. What about this crazy thing, the sine squared of S equals 1/4? Well, again, there's no sine squared on my cheat sheet, right? These are our sine values or y values, so we have to basically fix that. Easily done. We'll just take the square root of both sides. Now, again, be careful when I introduce that square root. What I also have done is introduce a plus minus. So we're looking at the sine of S equals to positive 1/2, or we're looking at the sine of S equaling to negative 1/2. So essentially, we're looking at all quads. And we're looking at all the y values, right, where the y value is equal to 1/2 in all the quadrants. So just going around, it's equal to a half here at pi over 6, right? It's equal to, it's equal to a half here at 5 pi over 6. It's equal to negative a half here at 7 pi over 6. And it's equal to negative a half over here at 11 pi over 6. So there's actually 4 solutions there. Because of the square root, we've introduced a plus and a minus. So where is it positive? Up here. Where is it negative? Down here. Which angle matches up, or which arc length matches up with y being negative a half? Well, we found it, right? Pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Same thing's happening here. We'll begin by taking the square root. So we're basically looking at the cosine of s being positive square root of 3 over 2, or we're looking at where's the cosine of s equal to negative, right, square root of 3 over 2. And again, we're interested in the x values, and we're in all quads because there's 2 quadrants where it's positive, and there's the other 2 quadrants where it's negative. So all quadrants involved. So looking around at quad number 1, right, where is x equal to the square root of 3 over 2? Right here. So pi over 6 is one of our answers. Where else is it equal to square root of 3 over 2? Well, it's mirror image, right? Well, it's negative over there, but we want those two. So that's 5 pi over 6 for that guy, right? Where's it back positive? Excuse me, where's it negative again? Right here, right, at 7 pi over 6. And then it's positive right here at 11 pi over 6. Okay, so it basically has the same values as that one. We're still talking about a 30-degree reference or pi over 6 reference. So solid. So this next one, got to do a little bit of algebra. We get the tangent of s is equal to 1. If we divide everybody by that, we're basically looking at the tangent of s is equal to 1 over the square root of 3. Rationalizing that denominator, right, we're looking at the square root of 3 over 3. So where is that going to basically be happening? You know, especially where we have 1 over the square root of 3 over 2. Well, if you think in terms of x and y values, this is when we have 1/2, this ratio right there, over the square root of 3 over 2. It's positive, so that tells us we're in quad 1 and we're in quad 3. So we're looking for a y coordinate of 1/2 and an x coordinate of square root of 3 over 2 in quad 1 and in quad 3 respectively. So in quad 1, that's pretty easy, right? Right here, here's where y is 1/2 and x is square root of 3 over 2. So one of our answers is pi over 6. Where else is it positive? Well, in this quadrant over here. And looking at my ratio, there's a y, right? A negative divided by a negative is a positive. There's the 1/2, there's the square root of 3 over 2. So we're looking at 7 pi over 6. And I think I'm going to have to go and redesign my handout because I didn't mean for that all to happen. Everybody's the same, pretty much the same 30-degree references, but hopefully you get an idea on how to solve that. That doesn't always happen where we kept using that same old 7 pi over 6. But there's your cheat sheet again. We're kind of solving equations. Again, the S is telling us we're in radian mode, and then I'm just using previous knowledge with this now new knowledge that sine is the y value and cosine is the x value, and I'm mixing and matching it for tangent and just using that knowledge for cosine and sine. So it is, I would agree, that is kind of cool, right? Nice little cheat sheet there to have your little your unit circle. All right, but again, this is only when we're talking about nice, perfect special angles. So more later, and I'll do that in another video coming soon.